Alrighty, in this video we are going to be talking about inscribed angles and tangents. With inscribed angles, there are going to be three big types that you have to know. So the first one is going to be your basic irregular schmegular inscribed angles. The second one is what happens if we are intercepting a diameter, and then what happens whenever we have overlapping arcs. So for the first one, an inscribed angle is going to be an angle with its vertex on the circle, with the two sides that are chords. An intercepted arc is the arc that lies between the endpoints of the inscribed angle. So in this case, AC would be your intercepted arc. The degree of the inscribed angle here, so in this case ABC, is always going to be equal to half of the measurement of the intercepted arc. So in this case, I could say that if I have the measurement of ABC, then that's going to be equal to 1/2 of the inscribed and 1/2 of the intercepted arc. Now, if an inscribed angle intercepts a diameter, then we know that it is a right angle. Now, how do we know that? Well, let's think about this. If we have a semicircle here, and that is my intercepted arc, then my inscribed angle, remember, is always going to be half of my intercepted arc. And if my intercepted arc is 180 degrees, 180 degrees divided by 2 is 90 degrees, which means that A has to be a right angle. So anytime your inscribed angle intercepts a diameter, it passes through the diameter, we know that your inscribed angle is going to be a right angle. Now, if we have two inscribed angles that intercept the same arc, then the two angles are going to be congruent to each other. So for example here, if I were to look at angle ABD here, notice how my intercepted arc is arc AD. But if I look at the inscribed angle ACD, it also intercepts AD. So we know that these two angles right here are going to be congruent to each other. So we know that ABD is going to be congruent to the measurement of angle ACD. All right, so let's look at some examples here. For number 1, we want to find the measurement of WXY. Notice how we have arc WY, and that's going to be my intercepted arc. And my inscribed angle is always going to be half of that. So 62 divided by 2 is 31 degrees. All right. So we have the inscribed angle being 113, and we want to find the measurement of arc DGF. In this case, we are just going to multiply by 2. So 113 times 2 is going to give us 226 degrees. For number 3, notice how we have an intercepted diameter with PR. It passes through the diameter. So in this case, we know that angle PQR has to be 90 degrees. Very important there. For number 4, we want to find the measurement of arc BC. This is going to be important in terms of what we are trying to find. We are not trying to find the intercepted arc. In this case, that would be 94. We're trying to find the measurement of BC. Now, if this is 94 right here, and we know that we have a semicircle right here, then I could say 180 minus 94, and that is going to give us 86. And that's going to give us the measurement of arc BC. Now we could do the same thing for number 5, thinking about, hey, all of my angles will add up to 360. So if I were to add 53 and 65, I'm going to get 118 degrees. So if I do 360 minus 118, then I am going to get 142 degrees. No, 242 degrees, sorry, 242 degrees for this lovely big arc right here, arc JML. But since I want to find angle JKL, which is my inscribed angle, that's just going to be half of my intercepted arc. So I'm just going to say 242 divided by 2, which is 121 degrees. All right, last easy example here. We want to find out what RST and RUT is. So to find the measurement of angle RST, I'm going to highlight that, being this right here. And then RUT, I'm going to highlight that. That's going to be that right there. Notice how here, once again, your inscribed angles are going to be congruent to each other because they intercept the same arc, which is arc RT. Our goal now is to essentially find out what arc RT is based off of the fact that we have 64, 139, and 75. If I were to add all of them up, subtract from 360, we are going to get 82. So 64 plus 75 plus 139 plus RT is 360. RT is 82. And then half of that is going to be 41. So we know that angle RST and angle RUT are both going to be 41 degrees. Now, of course, you are not going to see the easy peasy lemon squeezy problems like 1 through 6. We are going to have to do a little bit of algebra, so something like number 7 and number 8, and of course, the other problems right here. We're going to see what happens there. I'm not going to do a lot of problems with algebra. I think once you know the formula and once you know the rule, you'll get used to it. So for number 7 here, we have 8x minus 9 being my inscribed angle. And then my intercepted arc, CE, is 158 degrees. So I could say that if I have 8x minus 9 and I have 158, my inscribed angle needs to be half of my intercepted arc. So I know that 8x minus 9 needs to be equal to 79. I'm going to add 9, which gives us 88. Divide by 8, which gives me 11. Same thing for number 8. I'm given the inscribed angle. I want to find the intercepted arc. The intercepted arc needs to be twice as big as my inscribed angle. So I know that's that right there. Needs to be 134. So 4x plus 58 is equal to 134. Subtract 58 from both sides. 76 is equal to 4x. Divide by 4, divide by 4. And that is how we get 19. Okay, let's do one more. Now, I do want you guys to look at the difference between number 9 and number 10. Notice how number 9 here, we are passing through the diameter. So we know that angle X is definitely going to be 90 degrees. Now, number 10 here, it kind of looks like WY is parallel to my diameter here. But since it does not pass through the diameter, we can't use my knowledge of angle X being 90 degrees. It also tells me that angle X is 114 anyways. So for number 9 here, we are going to set this equal to 90 degrees. Add 1, which is going to give us 91. Divide by 13, which gives me 7. Okay, let's do one more In this case, let's actually just do, let's do 11. All right, so you want to find x right here. You are given 92 being the inscribed arc, with the arc for AB, and then the arc for BC is 162. The inscribed angle is 7x minus 10. We kind of need to find out what the inscribed arc is, the intercepted arc right here, AC, what that is, and then divide that by 2 to get this lovely thing right here. So I'm going to do 162 plus 92 plus AC, which is what we're trying to find. That's going to be equal to 360. AC is going to be equal to 160 degrees, which means that my inscribed angle has to be 53 degrees. So I have 7x minus 10 is equal to 53. 7x is equal to 63. Divide by 7. X is equal to 9. All right. Now, as a quick little fact here for inscribed quadrilaterals now, if we have an inscribed quadrilateral, then the opposite angles are going to be supplementary to each other. So in this case, angle A and angle C is going to add up to 180 degrees. And then angle B and angle D are going to add up to 180 degrees. All right, so looking at, let's say, number 3 here, I think we should just jump in and do the harder problems. Looking at number 3 here, we want to find out what angle V, angle W, and angle X is based off of this information right here. The only thing that we know is angle Y, which is 51 degrees, which is a good thing because that's going to help us find out what angle W is, because that we could just say 180 minus 51. And if we do 180 minus 51 here, we get 129 as angle W. Okay, so once we get that, we need to figure out what angle V is, and we need to figure what angle X is. Now, notice how if I were to look at angle X, we kind of have 2 intercepted arcs right here. We have the 101 and we have the 67. So if I were to add 101 and 67, I'm going to get 168 as my intercepted arc. Now, if I divide by 2, that's going to give me the measurements of angle X, which is going to be 84 degrees. And then to find out what angle V is, we remember that the opposite angles are going to be supplementary to each other. So if I do 180 minus 84, I'm going to get 96 degrees for angle V. And that's essentially it for inscribed quadrilaterals in terms of your opposite angles being supplementary to each other. So add those two and set them equal to 180. You might have to do a little bit of manipulation like I did with number 3, but you'll be fine. So like number 4 here, your inscribed arc for angle D here would be 100 degrees, which means that D would be 50 degrees. All right, last thing on our lesson is going to be tangents. For tangents, a tangent line right here intersects a circle at exactly 1 point. And that, remember at the very beginning of the unit, we called that the point of tangency. A line is tangent to a circle if and only if it is perpendicular to the radius. Perpendicular to a radius drawn to the point of tangency. So in this case, A is a right angle. A is my tangent. P is my center. And then from here to here, we could draw a radius, PA. And we know that the tangent line here is going to be perpendicular. Now, how do we know if it's going to be perpendicular? Well, we just got to use Pythag. So in this case, for number 1, it's already set up for us, and we just got to figure out if Pythag works or not for this one. So we are going to pretend, can we make angle A be a right angle? Well, if I were to use Pythag here, is that going to be true? 64 plus 225 is equal to 289. 289 is equal to 289. So we know that that works right there. For number 2 here, we want to figure out if this is going to be tangent to circle P. So looking at A, it kind of looks like it's a right angle. We have 11 square plus 14 square plus, we need to figure out what, well, not plus, equal to, equals, let's see. We have a 5 here, but we don't have anything here. But notice how point P right here, this represents a radii. And we already know that here, this is a radii of 11. So that means that this is going to be 11 also, which tells me that my alleged hypotenuse is 16 square. So we have 121 plus 196 is equal to 256. But the problem is 317 is not equal to 256. So I know that this right here is not a right angle. So not a right angle. Sad. All right, so sometimes you might need to find out what the value of x is for our circle so that we know that it is definitely a tangent. So looking for this one right here, we have 7, 19, and x. X is going to represent my hypotenuse. So that's just going to be 7 squared plus 19 squared is equal to x squared, which means that x is equal to 7 squared plus 19 squared. And if I were to simplify that, I'll get 20.2. All right, likewise for number 5 here, I want to figure out what x is. So I'm going to have 24 squared plus 10 squared is equal to my hypotenuse. Well, in this case, my hypotenuse, let's just name this y for now, and then we'll just work backwards. Now, if you solve for y, we are going to get, let's see, 576 plus 100, which is 676, which is y squared, which means that y is 26 whenever we take the square root. Now, if the whole hypotenuse is 26, and we also know that my radius here is 10, this tells me that y, if this is 26, this tells me that my x value here has to be 16. So we know that here, x is equal to 16. All right, one more topic. Sometimes your point of tangency, they will connect to an outside point here. So in this case, if I have 2 tangent lines, they will connect here at point B. And if that happens, then the 2 tangent lines are going to be congruent to each other. So this tangent line and this tangent line are congruent to each other. Which then gives us a direct result of this lovely thing right here, where if a polygon isn't circumscribed around a circle, then all of the sides are tangent. Now, circumscribed is probably going to be a new word for you guys, but to remember that our root word of circum is around, so around the circle here, all of the sides are going to be tangent to each other. So that means that DA is going to be equivalent to AF, FC is going to be congruent to EC, BE is going to be congruent to BD right here. All right, so for number 10 here, I'm going to find X. So these right here are going to be congruent to each other. They did not draw the radii, but I'm going to draw it here just so that you know why my relationship works. And then I'm going to set them equal to each other. Once you do that, I'm going to subtract the 5x, and then I'm going to add the 19. Add the 19 gives me a 42 is equal to 3x. And then this tells me that x is 14. Last one, number 13. So, well, let's not do 13. Let's actually do 14. So for 14, we want to find the perimeter of quadrilateral PQRS. So in order to do that, we need a couple of things. We need to figure out what this side is, and we need to figure out what this side is right here. Well, if this is 23 right here, then we also know that this is 23 right here. And if PQ is 37.5, then this point right here to Q needs to be 14.5. Now, if that's 14.5, then this here is also going to be 14.5. This right here is going to be 27.1. And if the whole segment right here is 52.5, 52.5 minus 27.1 gives us 25.4, which means that this right here is 25.4. And then if I add all of the segments up, I'm going to get a perimeter of 180. All right. I know this was probably a long video, but once you're done with this, work on the exit ticket problems. And then once you're done with that, do the Delta math problems. Now, as always, make sure that you guys complete the exit ticket problems to 100% so that you can unlock the next lesson.